Hi guys, good day. So I will be discussing through this video the kinematics in one dimension or horizontal motion word problems. Okay, so start tayo with the ideal method of solving problems. So I will be giving you these certain guidelines, but of course, it would still be dependent on your part kung saan kayo mas nadadalian na isolve yung problem. Pero much better if you can follow these guidelines because ito kasi yung ideal natin para mas madali natin siyang ma-solve. Okay, so the first one is for us to, of course, right after you read the problem, you have to analyze, and it would help you analyze if we're going to draw a sketch of the situation. And the second one is for us to identify the given. Third is the unknown. And then after you identify those two, we will be that will be the time that we will have to choose one of the equation among the 5 equations that we have. And before you substitute or proceed to the solution, you have to derive first the working equation. Okay, so I will be requiring you to derive the working equation for the unknown quantity. Okay, so if ever that you will be having a formula, but let's say for example, you already chose the right equation to be used for you to solve the unknown. But that is not the working equation for that unknown. So you have to derive first the working equation before you can proceed to the solution. Okay? So as I mentioned multiple times, because it would help you practice your algebra skills kasi kailangan nyo maalala yan. Ma-practice nyo siya at least by heart. When you go to college, talagang kahit paikot-ikutin kayo sa algebra, at least you know. Diba? So, basics rin kasi yan ng calculus and all the other mathematics, especially if you are on the engineering field. Okay, but of course, it would still be helpful for those who are on allied. Hindi naman natin sila, kumbaga, sinesegregate. It would still be beneficial for everyone. Yun nga lang, of course, it would be more beneficial on the part of engineering students. Supposed to be engineering students. Okay? Yan. Sige. So, diretso na tayo. Let's have the first problem. Okay, so according to this problem, an airplane accelerates down a runway at 3.20 meters per second squared for 32.8 seconds until it finally lifts off the ground. So determine the distance traveled before takeoff. Okay, if we're going to follow the guidelines that I gave you a while ago, the first thing that we have to do is, of course, internalize the problem. You have to analyze ano ba yung nangyayari dito sa situation or binigay sa yung situation. So, it would be helpful if we're going to illustrate. So, let's try to illustrate. Okay, pagpasensyahan na lang yung drawing ko. Okay, so sabi kasi doon, meron daw, if you were able to tawag nito, kung nakasakay na kayo sa eroplano, I think you have an idea na, di ba before talaga siyang lumipad, meron siyang certain distance na ita-travel bago siya mag-take off o yung makaalis dun sa lupa, sa floor, sa ground floor. Di ba? So, yung moment na yon na paakyat na siya or palipad na siya, that is what we call take off. And before that happens, mula doon sa start ng position ng airplane, meron siya munang certain distance na ita-travel para makagain siya ng needed acceleration para makapag-take off siya. So, yun actually yung tinatanong dito sa problem natin. Kasi sabi dito, nag-travel daw si airplane with an acceleration of 3.20 meters per second squared given the time of 32.8 seconds. So, yung itinagal nung pag-travel niya dun sa distance na yon needed for that to take off is 32.8 seconds with that value of acceleration which is 3.20 meters per second. So, tinatanong sa atin dito is what is the value of that distance traveled before the airplane take off. Okay, so try natin siya i-illustrate. So we have here, ito yung certain runway niya. Meron kang runway. Okay, and then dito sa airplane nung umpisa. Imagine niyo na lang airplane yan. Yan, ayan yung ating airplane nung umpisa. And then, it traveled for a certain distance until such time na na-achieve niya na yung kanyang acceleration, which is that given value. And on this moment, dun na siya mag-take off. Okay? Or lilipad. Yan, so andito na si airplane. Now, we are only concerned with this situation. Yung moment na nag-start siyang tumakbo hanggang doon sa moment na palipad na siya. Okay, nung moment na lumipad na siya, hindi na yun kasama. Nung doon lang tayo hanggang sa moment na pa-take off na siya. Okay? Yan, sige. So right after you sketch out, at least you would be able to visualize the situation. Next thing to do is to write all the given. So ang nakalagay doon na given natin, we have the acceleration. So acceleration niya is 3.20 meters per second. So lagay natin 3.20 meters per second squared. Oh, kindly bear with me. Medyo maingay yung kapitbahay namin na bata. Okay, and then the next one is the time. So aside from the acceleration, we are also given the time, which is 32.8 seconds. Okay, so 32.8 seconds. And then, we are asked to solve for the distance traveled by this airplane. So, since we are referring to, or we are dealing with horizontal uniformly accelerating motion, our symbol for the distance traveled by this airplane is delta x. Okay, or change in x. As simple as that. So, ito po yung ating nawawala. Ayan. So, from that point na nag-move siya hanggang doon sa point na pa-take off na siya. Okay? So, we are already given this 3. Ngayon, if you are going to remember, we actually have 5 kinematic quantities and you should take note of this 5 because the following are the ones that you will be solving for o kaya hahanapin mo doon sa problem along the way. 5 lang sila. Okay, and you have to take note para hindi ka malilito. Ano ba yung mga wala dito? Ano ba yung mga given, etc. Okay, so ano ba yung 5 na yon? If we're going to enumerate all, we have, of course, just to mention, yung mga nakalagay na dito, you have acceleration, time, delta x, and then the 2 velocities. Ano yon? The initial velocity, and then the final velocity. Okay, so yan silang dalawa. Ngayon, out of this 5, from the problem, we only have 2 explicit given and then 1 unknown. So, merong dalawa na hindi talaga nabanggit. Okay? So, itong dalawa na to, si acceleration at saka si time, they are explicit given. Ano ibig sabihin nun? Talagang ibinigay sila, binanggit niya yung value doon sa problem. Kaya explicitly, sinabi siya, given. Ngayon, the other 2 quantities that we have, which are initial velocity and then the final velocity, they were not mentioned. Okay, pero, kasi we need at least, we actually need a clue for us to find out which among the 5 equations that we have should we use. Ito yun eh. Itong 5, oh. So, kailangan mo ma-identify sino ba sa kanila yung isa pang missing quantity kasi meron tayong mga tinatawag na implicit given. Okay, ano ibig sabihin nun? Yun yung mga given na hindi siya binanggit doon sa problem, pero if we're going to analyze the situation, actually, merong value yung quantity na yun. Ano ba yung tinutukoy ko dito? If we're going to go back to the situation, which is dito, di ba nag-start siya nang wala pa siyang movement. And then, so, andun mo makikita actually yung yung initial velocity natin. So, ang initial velocity mo dito sa point na to, na nag-start siya na-start nating in-analyze yung situation. Ay, yan, nailagay ko na. Na-start mo na in-analyze yung situation. And then, dito naman, yung magiging final velocity mo is yung moment na pa-take off na siya. Kasi yun lang naman yung situation na i-analyze natin. Because we are to get the delta x from these 2 points. Okay, so kaya sila lang yung magiging concern natin na initial and final velocity. So, depende sa situation eh. Pwedeng ang final velocity mo maging 5 seconds after the takeoff from the start until 5 seconds after the takeoff. So, depende yon. Pero in this particular example, ang ating final velocity is limited only on that point wherein this airplane took off. Okay? Yan. Ngayon, why did I write here 0? If we're going to analyze our situation, di ba sabi even though hindi siya binanggit ha, pero kung i-analyze mo situation, ang sinasabi niya kasi dito, ano ba yung distance na tinravel ng airplane para makapag-take off siya? So, syempre, you would have to consider the very beginning of the movement of that airplane. So, ano yun? Mula nung umpisa pa lang, di ba hindi naman talaga siya gagalaw eh. Alam niyo di ba, yung mga aeroplano nakapark lang yon, magpapasok ng mga tao, papaakyat, and then pag complete na, tsaka siya magta-travel, di ba? Until ng straight line, di ba? Kung mapapansin, hindi naman siya talaga actually straight line, may mga iba na nakakaikot pa eh. So, ganon, magta-travel siya ng certain distance, and then yung certain distance na yun yung kailangan niya para makuha niya yung needed acceleration before takeoff. So, since we are asked to get that distance, kailangan may consider yung pinakaumpisa. Kasi from the context of the situation, sinasabi niya ano yung distance na tinravel niya para makapag-take off siya. So, hindi mo naman po pwede i-consider na dito lang sa gitna yung distance na yon. So, syempre yung pinakaumpisa ay ano ba yung pinakaumpisa? Nakastop pa lang yung ating airplane. So, we can say actually that the initial velocity is 0, even though it was not stated in the problem. But, out of analysis, we were able to conclude that the initial velocity is 0. Kasi nga, ang minimeasure mo yung kabuuan ng distance. Para makuha mo yung kabuuan niya, yung pinaka-umpisa ka mag-i-start, wherein nakastop pa yung aeroplano. Okay, so we have here another given which is implicitly stated, si initial velocity. So, si initial velocity is 0. Okay. Ngayon, guys, so since you already have here the initial velocity which is 0, we now have 3 givens. Okay, and aside from that, we also know the other quantity which is the unknown quantity, si delta x. Okay, so out of these 5 kinematic equations, meron kang given na acceleration. Teka lang. Nating red. Yan. So, meron kang given na acceleration, meron ka rin given na time. Itong si delta x, even though hindi siya given, pero siya yung pinapahanap. So, kasama na rin siya doon sa nabanggit sa problem. And then, si initial velocity, it was implicitly stated out of analysis. Ngayon, itong natitira natin, si final velocity, hindi siya nabanggit sa problem, and even if you're going to analyze it, meron siyang certain value talaga. 'Di ba? So, ano ba yung certain value na yun? Yun yung hindi natin alam. Okay? So, ito yung tinatawag natin na missing quantity doon sa ating problem. Okay, so since this missing quantity is not even mentioned or even through analysis, hindi mo makukuha yung value niya kasi merong certain value yan eh. 'Di ba? From this moment na nag-start siya na mag-move until ma-travel niya yung certain distance na hinahanap natin, meron siyang value ng final velocity para makapag-take off siya. Hindi naman po pwedeng 0 yun eh. So, yung certain value na yun, that is not what we don't know as of now. So, since hindi naman siya pinapahanap doon sa problem, ang hinahanap lang naman kasi dito, ang tinatanong sa atin is to get the value for the distance or the delta x. So, even though you know that final velocity has its certain value for this particular problem, hindi mo na muna siya concern. Kasi hindi naman siya yung pinapahanap doon sa problem. Pero, ano yung use niya sa atin? This one would guide us in identifying the right equation to be used for this particular problem na ma-solve natin yung delta x. Okay, so ito yung tinatawag natin na missing quantity. Yan, siya yung ating missing quantity. Again, ano yung gamit niya? It would guide us to determine the right equation to be used for us to solve the problem. Okay, so pag sinabi nating missing quantity, guys, hindi siya yung ano ha, yung unknown doon sa problem. Although unknown talaga siya, pero hindi kasi siya yung unknown na hinahanap or what to look for in the problem. Missing quantity siya in the sense na hindi siya nabanggit na problem at saka hindi rin siya hinahanap talaga. Okay? So, guide lang natin siya para mapili natin out kasi 5 to eh. Out of this 5, ano yung pipiliin mo dito na appropriate? So, yung missing quantity na yun na hindi nabanggit sa problem, yun yung mag-guide sa'yo kung ano yung equation na pipiliin mo or gagamitin natin. Okay, so since our missing quantity for problem number 1 is final velocity, looking by observing or analyzing these 5 equations, makikita natin na si third equation, nasa sa kanya yung missing quantity na final velocity. Okay, so since missing quantity dito ay final velocity, it only means that in this equation, lahat ng quantities mo except final velocity is included in this equation. Okay, laging ganun ang analysis niya. Let's say sa number 1, missing quantity ko delta x. So out of the 5 quantities, all the other 4 are included in this equation. Makikita ninyo, ayan, andyan si acceleration, time, initial velocity, final velocity. So, 4 out of 5. Ano yung isang nawawala? Si delta x. Same thing with 2, 3, 4, and 5th equation. Okay, so katulad dito, sa number 2, the missing quantity is acceleration. So, you have the delta x, final velocity, initial velocity, and then the time included in that equation. Same is true with the third equation which we will be using. Bakit siya magiging applicable? Kasi unang-una, andito yung unknown na hinahanap natin which is si delta x. So, syempre, essential yun because you are looking for that quantity. So, dapat included siya doon sa ating equation. So, check yun. And then, aside from that, all the other given that we have na nakuha natin or na-identify natin sa problem, we have VI, A, and then T. All of them are part of the equation. Okay, so, masasolve mo na ngayon si delta x. Okay, what if gumamit ka ng other equation aside from number 3? Would it be possible for us to solve delta x? Check natin. For number 1, we are looking for delta x pero it's the delta x that is missing for number 1. So, hindi siya possible. Number 2, we have the delta x, pero aside from the delta x, we also have the final velocity. So, kapag ito yung ginamit mo, dalawa quantity ang nawawala doon sa equation. So, it's not actually, it's possible, pero it's not easy. Bakit ko nasabi yun? Kasi, magsa-substitute ka ulit ng panibagong formula dito kay final velocity para matanggal siya at mapalitan mo siya ng other quantities equal to that. It's just the same as deriving the next equation which is the third one. So, medyo papahirapan mo ng konti yung sarili mo, although possible naman siya if you're going to choose any other equation aside from number 3. Okay? Kasi hindi po pwedeng dalawa silang nawawala sa isang equation. Hindi mo masosolve yun. Okay? Unless you're going to substitute another equation in replace of the other missing quantity. So, katulad lang din yan kay numbers 4 and 5. We cannot use them because both of delta x and then final velocity are included in the equation. Parehas silang nawawala. So, kailangan isa lang kasi ang nawawala doon sa ating equation. Okay, para ma-solve mo siya. Okay, so we have here the third equation to be used for that problem. So, let's try to solve for that. Let's try to solve for delta x now. Okay, so our third equation is delta x. So you have delta x equals V I T yan, plus 1/2 A T squared. Now, before we proceed substituting our values here, we can actually simplify this one first. Ano kaya yung pwede nating i-simplify or i-cancel out dito? So, if we're going to look at our given, we have a value which is equal to 0, which is our initial velocity. So by just looking at our equation in here, yan. So, makikita natin that we have here the first term on the right side of the equation, we have VIT. So, that's only two quantities ha. The VI, ito ang I na to is just a subscript. So, that's initial velocity and then the other quantity is time. So, the product of these two would actually give us 0. Paano ko nasabi yon? Because the initial velocity is 0. So, even though the time is 32.8 seconds, actually, any other value aside from that, mas malaki man o mas maliit, aside from that value, it would still give us 0. So, para sa umpisa pa lang, masisimplify na kaagad natin yung equation natin and you would not bother substituting the values. You can simply cancel out this one already. So, kahit na wag mo lagay ito sa taas, lagyan mo lang siya ng guhit ng ganyan and then 0. So, that would tell us that you cancel it out because one of the variables or quantity here is equal to 0. Kasi diba, any number multiplied to 0 would give us 0. So, yeah, that's it. So, we can simplify our equation through that. And then, just rewriting our equation, it would give us delta x equals 1/2 a t squared. So, what's the next thing to do? You check whether the equation here is the working equation for your unknown quantity. Ano ba yung unknown quantity natin? We have delta x. So, si delta x, this is actually the working equation of delta x already. Ano ba yung ibig sabihin ko kapag sinabi nating working equation? So, when we say working equation, that would give us the equation of that variable, meaning, all the other quantities are on its other side. Siya lang yung nandoon sa isang side niya. Paano kapag sinabi natin na using this equation, we are to find for the acceleration? So, would you still be using this one as your working equation for acceleration? Siyempre hindi, because this one is the working equation of delta x. Pero, we can derive the working equation of acceleration from here. Ang usual kasi nangyayari, or yung some of the students, what they are doing is that they are substituting the values and then doon sila nagsosolve along the way. Although okay naman siya, wala namang mali doon, pero of course, as I mentioned, it would be better if we're going to practice applying our algebra skills. Okay? Para hindi nyo siya nakakalimutan. And if you're going to repeatedly do it, mas maano siya kahit na mas mahabang panahon na hindi niya siya inaral, if you were able to do it multiple times, mas matagal yung retention. Okay? So, kahit na mahaba yung bakasyon ninyo, let's say, after you graduate senior high school, if you are doing it for 1 year, I don't think na madali siyang mawawala sa'yo eh. So, mas maganda na ipapractice natin siya for that long period of time. At least the retention would be longer. Hindi kayo masyado mahihirapan sa college. Okay? So, I will be requiring you to derive the working equation of the unknown if ever it is not given from the general equation. Kasi this one is our general equation. Si delta x equals to VIT plus 1/2 AT squared because this one came from the 5 kinematic equations or UAM equations. Okay. So, since ang hinahanap naman natin si delta x at sumakto naman na siya yung kakalabasan ng working equation, ay siya naman yung equation ng ating general equation, then we can simply use this one. Kasi ito na nga yung ating working equation for delta x. So, no need to derive. Now, what's the next thing to do? We can now substitute the given values. So, diretso tayo, equals to 1/2. A is equal to 3.20 meters per second squared times, you always have to include the units. Okay, that's how you write the complete solution. Okay, and then 32.8 second squared. Kasi dun nyo rin siya guys, check whether the units would cancel out to each other. May mga pagkakataon kasi na, let's say si acceleration is kilometers per hour. Tapos yung time mo, seconds. So, would that work out? Can you multiply them to each other? hindi kasi siya magka-cancel out. It would give you numerous units which would not pertain to the distance. Hindi kasi maka-cancel out yung tawag ito, second squared sa kanila. So, sa case na to, since pareha silang naka-second squared, then you can proceed already solving this one. With, 'di ba? Kasi maka-cancel out sila. Pero, if they are not the same in terms of the unit, you have to convert one of the two first. Para pagka parehas na sila, that's the time that you can actually proceed solving the unknown. Okay? So, you have to include the unit whenever you are writing your complete solution. That's one way for us to check whether we can proceed solving the problem. I mean, solving it through your calculators kasi nga maka-cancel out yung mga units. Diba? Kung i-check nyo naman dito, this would give us meters per second squared, and the other one is 32.8 naka-squared, tas si second squared din. So, maka-cancel out siya because you have here meter dot second squared. Ang kakalabasan mo kasi dyan is meter over second squared times second squared. So, maka-cancel sa second squared, it would give us meters, which is the unit for distance or delta x. So, let's proceed. If you're going to do the math, you input it on your calculator. Just to double check, it would give us 1,721.34. So you have here 1,721.34 meters. Okay, so delta x. So that is actually the value that we are looking for doon sa ating problem. So, guys, if you're going to tawag nito, if you're going to check whether the answers are parallel to each other or the same from the PowerPoint that I gave you, yung in-upload ko doon, hindi ko na siya inedit kasi magbibigay naman ako sa inyo ng complete. Aside from this video, I will also be giving you the PDF file for the complete solution of the 10 problem sets that I gave you through the PowerPoint. So, meron naman din kayong PDF file for that. Ngayon, if we're going to compare the answer, actually, may mga answers doon na hindi sila magmamatch. Bakit? Kasi po, yung mga sagot dito sa ating PowerPoint is based on significant figures. Okay? So, katulad nito, if we're going to look at the given, yung mga explicit given dito, we only have the maximum number of significant figure is 3. And we know through the rules of significant figures, multiplication and division, that the final answer should follow the given with the least significant figure. So in this case, that is 3 significant figures, right? So from our answer, kasi actually, ang makukuha mo talaga dyan sa calculator is 1,721.34. And any other, meron pang kasunod yan, ni-round off ko na lang ng 2 decimal place. But why is it that the answer here on the PowerPoint is 1,720? That's because it followed the rule of significant figure. So that would be the case if you are going to use significant figure. Pero as I mentioned last time when we ended our discussion on conversion of units, hindi na natin siya i-apply along the way. Okay? Since medyo mahirap nga yung setup ngayon, and also the topics, para hindi na kayo masyadong burden. Pero at least you are familiar with the rules of significant figures and the other fundamental concepts that we should know before we proceed to problem solving. So, eto, just if you were wondering lang, just to mention that the answers here are or the answers on the PowerPoint are based on significant figure. So, if ever na magkakaiba sila doon sa PDF na ibibigay ko and then dito sa video natin, yung mga sagot, that's because po that the answers on the PowerPoint are based on the significant figure. But in our case, I would not be strict with the significant figures anymore. You just have to express your final answer with 2 decimal places. Okay, you round it off into 2 decimal places. So, ganun lang tayo palagi. Okay, now what if your answer is whole number? Kailangan mo pa ba siyang lagyan ng 2 decimal place? Hindi na po. Okay, so if ever na yung answer mo is more than 2 decimal place, that's the time that you will be having 2 decimal places. Pero let's say if your answer is 10.9, hindi mo na siya kailangan ng lagyan ng 0 pa. Okay, magiging dalawa lang tayong decimal place if it is more than, basta that's the maximum number of decimal place just to be uniform for everyone. Pero kung whole number ang sagot mo, let it be whole number. If 1 decimal place, then 1 decimal place. Okay? So, yan. For number 1, our answer is 1,721.34. Okay, so proceed tayo sa question or problem number 2. Okay, so problem number 2 tells us that a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. Okay, so what's the first thing to do? Of course, you analyze the problem. Much better if you can read it multiple times. Kung hindi mo pa siya nagigets na isang basahan, okay lang yun. Basahin mo siya for twice or third time. Basta as long as maintindihan mo yung problem, and then that's the time that you can proceed. Okay? Yan, sige. So, ang situation natin dito is we have a certain car na nag-start from rest. When we say at rest, wala siyang movement. Okay, so dun pa lang, malalaman mo na kaagad that your initial velocity is 0. And then, it accelerates uniformly over a time of 5.21 seconds. So, anong ibig sabihin, no? Nag-accelerate daw siya uniformly. If the acceleration is constant over time, then the velocity is constantly increasing. Pabilis siya ng pabilis. Pero yung acceleration niya, pare-parehas lang. Okay, gano'ng katagal? 5.21 seconds at yung layo niya or distance na tinravel is 110 meter. So, the problem is asking us to solve for the acceleration. So, gawin muna natin. Actually, dito kasi guys, sa uniformly accelerating motion, horizontal, and even for the vertical, pare-parehas lang ang magiging illustration mo dito. Actually, you have the portion for the initial velocity and then the portion for the final velocity. So, ganun lang siya palagi. Actually, mas magiging helpful talaga sa atin yung sketches kapag sa projectile motion na siya. Wherein, the horizontal and then the vertical motion are combined into two. So, yun yung medyo complicated na ng konti kasi pinag-combine mo na eh. Yun talaga, mas kakailanganin ninyo ng sketches. Pero sa part na to, I think medyo kaya pa rin naman. Pero for the sake of visualization, itry natin siyang i-drawing or i-sketch. So, you have a certain car. Yan. Tapos, nag-start daw siya from rest. Ano ibig sabihin nun? So, hindi pa siya nagmo-move. Kino-consider natin yung situation na yun. So, from that moment, na naka-stop siya until mag-start siya mag-move until such time na na-achieve niya yung acceleration na yun for a certain distance of 110 meters, yun yung i-consider natin na final velocity niya. So, na nakaabot na siya ng 110, nakaabot na siya ng 110 meters sa distance, kung ano man yung final velocity niya doon, then yun yung i-record natin as its final velocity. No other points aside from that, kasi yun yung ating kino-consider na situation sa problem. Okay, so, kung i-measure natin, actually dito ang kanyang distance, si delta x is equal to 110 meters. Yan. 110 meters. And then, aside from that, we are also given the time. Gano'n siya katagal na nag-travel for that certain distance? That is equal to 5.21 seconds. 5.21 seconds. And then, what we are asked to solve for is its acceleration. Yeah. So, out of the 5, ganun ulit ang gawin mo. Medyo nalilito ka pa. Enumerate mo yung 5 kinematic quantities. We have the acceleration, time, distance, initial velocity, and then the final velocity. Sino-sino sa mga to yung given at sino yung unknown, sino rin naman yung missing quantity. Okay, so ang given natin, we have the initial velocity because as stated from the problem, it is started at rest. From rest. Di ba nakalagay doon? Started from rest. Yun yung umpisa natin. So, VI is given. Even though hindi siya sinabing 0 ha, pero pag sinabi mo kasing at rest, hindi gumagalaw. So, ano meaning nun? Wala kang velocity initially. Okay? And then you have the time as well as the acceleration. Aside from that, wait lang. We have the time and then the acceleration is given but it is the unknown. Okay, siya yung nawawala. And then we also have the given value for the distance. Now, final velocity, you know that that would be the final velocity at the end of 110 meters. Pero, the problem is not requiring for us to solve for this and it's not even stated in the problem. Okay, so this one would be our missing quantity. Since the quantity that is missing in here is the final velocity, if we're going to check our 5 UAM equations here, the equation that we will be using would be the third one. Okay, kasi siya yung walang final velocity na included doon sa kanyang equation. We should be choosing that kind of equation kasi kung any other equation aside from equation number 3 included sa final velocity, hindi nga siya given. So, kailangan ang nawawala lang doon sa equation na yon is si acceleration. Siya lang dapat yung unknown doon. All the rest of the quantities involved in that equation should be given. Okay, para ma-solve natin siya. Now, so let's use again the third equation. So, that would be delta x equals VIT plus 1/2 AT squared. Okay, and then we can also apply the same thing that we did a while ago for problem number 1. We can readily cancel out the first term, which is VIT, because VI is equal to 0. Any other, whatever the value of time is, it would still give us 0 for this term. Okay, so just to simplify, let's cancel it out already. So we have here just the 1/2 AT squared for the right side of the equation. Ngayon, we cannot proceed substituting the values yet because this is not this is not the working equation for acceleration. Diba, our unknown is acceleration. That is what the problem is asking us to solve for. Pero, hindi pa ito yung working equation natin for A. So, what should we do? We have to derive first before we can substitute. As I told you, I will be requiring you to do that. So, let's try to derive the working equation for A. What's the first thing to do? Eliminate mo muna si 1/2. So, you multiply both sides by 2. Nakaka-cancel out ito. You would have on the other side 2 delta x equals to 80 squared. So, we have to cancel out all the other variables or transfer to the other side all the other variables aside from A, which is our unknown. Kasi kailangan nga siya lang yung matitira doon sa side na yon for you to call that it is the working equation of acceleration. So, cancel out natin si t squared. Ano lang naman yan guys eh, di ba? Babaliktarin nyo lang lagi yung yung operation. So, ito, naka-multiply sila. So, ano bang kabaliktaran ng multiplication? So, para ma-cancel mo siya, iti-divide mo siya, both sides. Ito namang isa, ito kasi fraction eh. So, medyo iba siya dito ng situation. Kasi, naka-divide dito yung 1/2, kaya siya nag-multiply. Although, dito sa term niya, naka-multiply siya kay a and then kay t squared. So, medyo ibang situation ito kasi fraction siya. Pero, if you have here variables that are multiplied to each other, you can cancel out the one of them if you're going to divide both sides by that quantity that you want to cancel out. So, in this case, that is t squared. So, both sides dapat yun para ang iyong equation ay maintained or walang mababago. So, makakancel itong si t squared. We now have this is the time that we already have the working equation for acceleration. And that is 2 delta x over t squared. So, dito pa lang po kayo magsa-substitute. Okay? Sige. So, let's try to substitute. You have here 2. What is delta x? Delta x is 110 meter times, divided by t squared. Our t is 5.21 seconds squared. Okay? Okay, so if we're going to solve for its value, it would give us 8.10 meters per second squared. So 8.10 meters per second squared. So checking on its units, wala naman tayong problem kasi just have to combine the two of them. Wala kang kailangan i-cancel out. So it would give us meters per second squared. So the answer for number 2 is 8.10 meters per second squared. Now, moving on to the third problem we have here. A race car accelerates uniformly from 18.5 meters per second to 46.1 meters per second in 2.47 seconds. Determine the acceleration of the car and the distance traveled. Okay, so what's the first thing to do? You have to analyze the situation, read it multiple times if you want, para talaga maintindihan mo siya. And then, if you prefer, you can sketch it out. Pero, that's a suggestion. It's still up to you. Much better yun na gawin. At I mean, mas talagang kailangan siya sa projectile. Pero this time, it would still be helpful if you do. Okay, so sabi doon, we have a certain car, sa race car. Sa racetrack. Tapos, nirecord natin yung kanyang initial and then final velocity. So, ang initial velocity niya ay 18.5 meters per second. So, why did I say that, conclude that that is our initial velocity? Because if you're going to analyze in here, sabi dito, from 18.5. So, ibig sabihin, yun yung unang velocity na na-record niya to 46.1 meters per second. So, that is the final velocity for that portion that we are analyzing. And actually, if you're going to use the concept of uniformly accelerating motion, it would tell us that 18.5 is the initial velocity. Bakit? Kasi, di ba, pag sinabi nating uniformly accelerating motion, habang tumatagal, mas, hindi mas sumasarap, mas, tawag na to, bumibilis yung velocity natin. So, dito, magiging una talaga dyan na marirecord is yung mas mababang velocity, which is si 18.5. Okay, and of course, aside from that concept, it was really stated in here that we recorded it from una, 18.5 hanggang doon sa 46.1. So, our initial velocity would be 18.5 and then the final velocity is 46.1. So, lagay natin. Initial velocity is 18.5 and then the final velocity as recorded in there. Kailangan laki natin ng konti. Ay, sobrang laki na. Okay, kita naman ninyo ata. 18.5 meters per second and then the final velocity is 46.1 meters per second. Now, aside from these two quantities, what are the other quantities that we were given here? So, aside from the initial and final velocity, we are also given the time, which is 2.47 seconds. So, lagay natin dito si time, 2.47 seconds. Ngayon, pinapahanap sa atin sa problem is the acceleration and then the distance traveled. So, we are to find first for the acceleration and then the distance. So, ito ay horizontal. So, we would be writing the symbol for distance as delta x. Okay, so, dito, kung makikita ninyo, lahat na siya, diba, ng anong pinapahanap. Ang mangyayari na lang dito, para ma-identify mo sino yung una munang magiging missing quantity is for you to check kung sino yung unang pinapahanap sa atin. Diba, meron tayong, diba, kung i-recall nga natin, meron tayong 5 kinematic quantities. You have the initial, velocity, final, time, acceleration, and then delta x. So, itong tatlo natin, yung unang, yung mga tatlong nauna, VI, VF, and then time. We have the given for these three. And then, itong dalawa yung pinapahanap sa atin. So, wala ka talagang actually missing quantity yung hindi nabanggit. Lahat sila nabanggit eh. Pero, what would be the equation that you are going to use para ma-solve mo itong dalawa? So, actually, wala namang problema dyan kahit unahin mo si A o kaya si delta X. Pero, para pare-parehas tayo ng gagawin, uunahin natin laging isolve yung naunang tinanong na quantity na unknown. Okay, so sa case na to, that would be the acceleration. So, para malaman mo kung ano yung value or ano yung paano mo makukuha si acceleration, since hindi pa naman included si delta x, yun muna yung gagawin mo missing quantity for that specific situation, since you are to find for the value of A. Okay? So, kung hindi mo i-include, kasi hindi naman po pwede sa isang equation, lahat sila kasama, walang ganun eh. Kailangan merong isang hindi kasama. Okay, yung missing quantity na itetreat mo as missing quantity. So, sa case na to, even though this one is one of the unknown, si delta x, for that particular situation, you have to, tawag nito, kailangan mo siyang i-consider na missing quantity for you to solve the acceleration, even though hindi naman talaga siya missing quantity kasi binanggit nga siya at pinapahanap pa. Okay, pero para ma-solve natin si A, we have to consider that one first as our missing quantity. Kasi siya yung hindi mai-include doon sa ating problem. So, isolve muna natin si A una. Okay, so since we are looking for A, and we have the given such as initial velocity, final velocity, and time, and then hindi included doon sa ating equation si delta x, you find for that equation na walang delta x. So, if you're going to look at this 5 equation, that is equation number 1. Okay? So, para ma-solve mo si A. Hindi kasi po pwedeng silang lahat nasa isang equation eh. Meron talagang isa na hindi included muna for the meantime. Okay? So, we have here, the first equation is VF equals to, okay, VF equals to VI plus 80. Okay, meron kang final velocity, meron tayong initial, nawawala si A, given si T. Okay, anong sabi natin kanina? Our unknown that we are actually solving in here is the acceleration. And as you can see, it is not yet the working equation for acceleration. So what should we do? We have to derive the working equation for A. And paano natin gagawin yon? So you have to transfer all the quantities to the other side. Of course, using or following the rules of algebra. So the first thing that we can transfer to the other side is the VI, since naman sila, addition ng kanilang separate na operation. So transpose mo lang yan. Then sa kabila, it would be VF minus VI this time. And still equal to 80. And as I mentioned, we are looking for the working equation of A, so we should cancel T. So, cancel natin by dividing both sides by T. Actually, ito yung yung equation mo for acceleration, di ba? Diyan lang din siya kinuha. Okay, and then, just rewriting the equation in here, we have A equals VF minus VI over T. Yan. So, we can now substitute because this is the working equation of acceleration. So, kung magka-substitute tayo, we have the value for final velocity is 46.1 meters per second minus 18.5 meters per second all over the time, which is 2.47 seconds. So, kung isa-solve po natin siya, it would give us, using your calculator, or kung kaya nyo mano-mano, it would give us 11.17. So, 11.17 meters per second squared. So, tignan natin sa ano. Yan. So, 11.17. Dito naka 11.2 siya kasi nga it follows the SF rules. Pero, in our case, since we are not very strict with the SF anymore, for these topics, Sa mga susunod din, 2 decimal places na lang tayo. Maximum of 2 decimal places or less, depending on your answer. Okay, so your answer here for the acceleration is 11.17 meters per second. Ngayon, hindi pa dito natatapos. Bakit? Because aside from the acceleration, we are also asked to get the value for this distance. So, delta x natin. Ngayon, dito guys, for the distance, since all of the 4 quantities are already given, initial velocity, final time, and then acceleration, actually, 4 ang pwede mong gamitin dito na equation. Okay? Kasi lahat dito, except equation number 1, are equation that you can use for you to solve delta x. So, ang pipiliin mo na lang dyan, para pare-parehas tayo, you would always be using the first one na makikita mo na applicable. Kasi lahat naman sila applicable eh. So, sa 2, 3, 4, 5, ang pipiliin natin na gagamitin is number 2. Bakit si number 2? Kasi, siya yung una doon. Okay? Mas madali lang dito. Actually, lahat naman yan sila. Pwede. Pero, just to be uniform for everyone, pare-parehas tayo, then, number 2 po ang gagamitin natin. But, even though you're going to use other equation aside from number 2, you would still get the same answer naman. For the sake of uniformity lang. Okay, so for number 2, for delta x, you would be choosing the second equation, which is delta x equals vf plus vi over 2 times time. Yan. So, no need to derive anything, and even the given, no need to write anything because it's all of the original givens were already written a while ago. So, all you have to do now is to check whether you have the working equation for delta x, or kung hindi, you have to derive. Pero since we already have the working equation for delta x, then we can proceed now to substitution. So, substitute tayo. So, for final velocity, that is 46.1 and then 18.5. So, 46.1 meters per second plus 18.5 meters per second divided by 2 times time. Ang time po natin is 2.47. So, times 2.47 seconds. So, kung isosolve mo siya, the answer would be 79.78 meters. 79 79.78 meters na lang. Okay, bakit? Lahat ng units natin per second makakancel out yan. Dito sa numerator mo, if you're going to add these two, it would still give us meters per second. Pag multiply mo siya doon sa 2.47, dun makakancel si seconds. Okay? Yan. So, that's why we have the meters for your distance. So, that's the answer for number 3. Acceleration is 11.17 meters per second. And then, delta x naman is 79.78 meters. Okay, let's have number 4. So, for number 4, sabi dito, a bike accelerates uniformly from rest to a speed of 7.10 meters per second over a distance of 35.4 meters. So, determine the acceleration of the bike. Okay, so ano yung una natin gagawin? Nakikita ninyo, no? Paulit-ulit lang tayo ng ginagawa. So, along the way, at least kahit papano, mas maaalala nyo na yung dapat ninyong gawin. Okay, so una, it's up to you, but much better if you can sketch it out. So, meron kang bicycle. Dito, actually, hindi ko alam yung drawing ng bicycle. Ayan, ganyan na lang. Okay? Yan. So, you have this bicycle. And then, it started from rest. So, 0 to a speed of 7.10 meters per second. So, nung umpisa daw, yung kanyang initial velocity is 0 since it mentioned that it started from rest. And after some time, naka-accumulate siya ng final velocity niya na kanyang final velocity now is equal to 7.10 meters per second. So, 7.10 meters per second. And aside from that, we are also given the distance traveled, which is 35.4. So, ang kanyang distance or delta x is 35.4. So, delta x natin is equal to 35.4 meters. Okay? And then, we are asked to find for its acceleration. So, ang acceleration po niya is our unknown. Okay, now, so what are you going to do next? You have to identify the right equation to be used. So, hindi ko nasusulat pero out of these 4 equation, ano sa tingin ninyo yung hindi na mention doon sa ating problem or our missing quantity? Sige, pag-isipan ng konti. It's the time. Diba? So, wala tayong time. Ibig sabihin, yun yung maiko-consider natin na missing quantity for this problem. For problem number 4. And it would tell us it would actually help us to identify the right equation to use in order to solve number 4, problem number 4. So, hanapin mo doon sa equations na yan, sino yung missing quantity niya ay t or walang time na included doon sa equation. Kasi hindi mo pa pwedeng gamitin yung ibang equation kapag nawawala na nga si acceleration, nandoon din yung time. Pareha silang nawawala. You will not be able to solve anything if both of them are present in the equation. Okay, so let us use the fifth equation since it do not contain the quantity of time. It is the missing quantity in this equation is the time. So, yun yung applicable na pwede natin gamitin. So, let's have VF squared. VF squared equals to VI squared plus 2A delta X. Okay, ano po yung hinahanap natin? We are looking for the acceleration. So, this one, the general equation, the fifth uniformly accelerating motion equation in here is not yet the working equation for the acceleration. So, we have to derive muna before we can substitute. Pero, we can simplify something before we proceed deriving the working equation for A. And that is the VI. Okay, pwede mo na i-cancel out yan para hindi na siya isasama doon sa derivation mo. So, cancel out natin. Again, bakit ko siya kinancel? Kasi po, this vehicle started from rest or 0. So, no need for you to include that one because it would only give us a value of 0. So, just rewriting in here, we have VF squared equals 2A delta X. Now, we can proceed to deriving the working equation for A, and that would be by dividing both sides by 2 delta X. 2 delta X. Kasi kailangan na matitira na lang dito si A. So, tanggalin mo si 2. Ayan, isa-isa ko lang. 2 delta X. And by doing that one, the quantity that would be left on the right side is the acceleration only. Now, since we already have the derived equation for acceleration, rewrite lang natin siya. So, we have here A, V, F squared over 2 delta X. Okay, and from here, we can now substitute our given values, which are VF, 7.10 meters per second, naka-squared, over 2 times delta X. Our delta X is 35.4 meters. Okay? And then, by doing that one, you check all the units in here, consistent naman. The numerator would give us meter squared over second squared. Yung sa baba, magbigay sa'yo ng meter. And through that, makakancel natin yung isang meter doon sa taas instead of meters squared, magiging meters na lang siya kasi makakancel dito sa baba. Ika-cancel itong baba. So, it would give us a unit of meter per second squared. So, since parehas naman sila, no need for us to convert, we can now proceed solving this one. And if we're going to input it on your calculator, it would give us 0.71 meters per second squared. So that's the value for acceleration. Okay, let's have the fifth one. For problem number 5, we have here an engineer is designing the runway for an airport. Of the planes that will use the airport, the lowest acceleration rate is likely to be 3 meters per second squared. The takeoff speed for this plane will be 65 meters per second. Assuming this minimum acceleration, what is the minimum allowed length for the runway? Okay, so medyo mahaba ng konti, di ba? Pagka unang basa mo dyan, siguro hindi mo pa siya muna talagang maiintindihan ng buo. So, much better basahin mo ulit. Okay, pero sa case natin, let's proceed to illustrating ano ba yung nangyayari doon sa, or sketching kung ano ba yung nangyayari doon sa problem. So, as usual, I mean, we are again given a situation about airplane. Pa-take off niya. Ay. Yan. So, ang airplane natin, syempre, nung mag-start yan na mag-move siya, meron, dito siya sa point na to na wala pa siyang velocity. So, ang initial velocity mo dito, ano ba siyang airplane? Yan. Okay. So, initial velocity mo, of course, would be 0. And then, sabi doon, binanggit yung take-off speed niya eh. Ang take-off speed niya daw ay, ano ba siyang aeroplano, guys? Okay, okay na yan ha. So, ang kanyang final velocity is given, which is, ayan, 65 meters per second. So, sabi dito the take-off speed for this plane will be 65 meters per second. So, yun yung velocity na kailangan niya para makapag-take off siya. So, yun yung end nung ano mo, 'di ba? Nung distance na yon. Okay, so that is 65. Since we are only asked to determine the minimum length allowed for the runway, yun kasi yung kailangan mo eh. Bakit mo ano yung ibig sabihin natin doon? Ano yung certain distance na kailangan niyang i-travel para ma-achieve yung 65 meters na yon. So, that should be the minimum length for the runway. Bakit? Kasi kung mas maiksi pa, doon yung length ng runway mo, susobra yung eroplano. Okay? So, dapat ang minimum length ng runway is that distance na kakailanganin niyang i-travel para makakuha siya ng speed or makagain siya ng speed na 65 meters per second. Okay? It could be longer than that. Okay naman yun, pero yun yung minimum dapat na length. Kasi yun yung kailangan ng eroplano para makapag-achieve siya nung 65 meters per second na kailangan niya para makapag-take off siya. Okay, bago siya lumipad. Or para makalipad siya. So, that would give, so for the final velocity, that is again 65 meters per second. So, 65 meters per second. Ngayon, sabi dito, if the minimum acceleration is 3 meters per second squared. So, sa lahat daw ng eroplano na meron sila doon, yung eroplano na pinakamababa yung acceleration niya is 3 meters per second. Okay? So, 'di ba, iba-iba kasi ang eroplano, merong maliit, merong malaki. So, depende yung magiging dependent doon actually yung acceleration ng eroplano na yon. Okay? So, iba-iba sila. Ngayon, sa lahat ng eroplano na nandoon sa airport na yon, yung eroplano na merong pinakamaliit na value for its acceleration is merong value na 3 meters per second. So, doon ka titingin sa, considering that minimum value for the acceleration, we are to find the distance na applicable doon sa aeroplano na yon. Okay? So, given that the acceleration of that particular airplane is 3 meters per second squared, 3 meters per second squared, we are asked to find for the minimum distance that that runway should have, considering the values of the kinematic values of airplane in here. So, siya po yung nawawala. Okay, so if we're going to look for, if we're going to identify the 5 kinematic quantities, ang nawawala po dito is the time. Okay, so since wala tayong time dito, siya yung may consider natin na missing quantity. So, missing quantity natin is the time, and by looking at this 5 equation, we should use the fifth one, just like nung previous problem natin. So, gamitin natin si fifth equation, which would give us vf squared equals to vi squared plus 2a 2a delta x. Okay? Yeah. So, vf squared equals to vi squared plus 2a delta x. Now, as I mentioned repeatedly, we could cancel out one of the quantities in here, which is vi, because that is 0. So, aside from vi, if you are given other quantities which are equal to 0, you can readily cancel out them from the beginning pa lang. Okay? So, dito kasi, madalas talagang pagkakataon na initial velocity natin is 0. Kasi almost all the things naman that we are analyzing started from rest. So, hindi siya nagmo-move until such time na magmo-move siya. Okay? Or makakagauge siya ng velocity. Yan. So, if we're going to cancel out this one, we are given vf squared equals 2a delta x. But for this particular problem, we are looking for the distance. So, 2a delta x, we have to transfer itong si 2a sa kabilang side. So, how do we do that? Kailangan mong i-cancel out by dividing both sides with 2a para matitira na lang po si delta x. So, we have here delta x equals to vf squared over 2a. Okay? And then substituting, we have here 65 meters per second squared over 2 times 3 meters per second squared. Okay, substitute lang tayo, di ba? Kasi that's already the working equation for delta x. So, by doing that, if you're going to do the math, it would give us 704.17 meters. So, that's our delta x. Okay, so pare-parehas lang yung procedure, guys. First thing to do is to sketch it out. If you don't want, at least you repeatedly read the problem until such time that you already are familiar with the problem or naiintindihan mo na siya. Kahit na i-visualize mo lang siya, pwede naman yun eh. Kasi simple pa lang naman to. One dimension pa lang tayo. And then, after that one, you have to write all the given and analyze the problem. Kasi there might be some quantities that are implicitly stated in the problem. Okay? And then, after you identify all the given, that's the time that you have to determine what is the unknown. Usually naman, nasa question form yan eh. Tsaka mababasa mo talaga kung anong pinapahanap sa'yo. And then, for you to determine what is the right equation to be used, doon sa 5 kinematic quantities natin, tingnan mo kung ano yung quantity na hindi binanggit doon sa problem. Okay? Or yung missing quantity natin. Okay? And because that would help you to determine the right equation to be used. So, once you identify the missing quantity, you go back to your 5 kinematic equations and you choose that equation with that has a missing quantity na nandoon sa problem mo. Okay? And then, write that specific equation. You check whether that is the working equation for the unknown. If not, you have to derive. Once you derive the equation, substitute, and then you write your final answer. Okay? Of course, before you write your final answer, you have to double check the units. Baka meron ka naman dyan kailangang i-convert. Pag wala naman, you can proceed. Tapos, that's your answer. Okay? So problems number 6 to 10, I will leave it up to you for you to solve. You can actually add this 5 problems for you to practice. You can use it when we will be having our examinations already. Actually, we have an upcoming quiz for horizontal motion, uniformly accelerating motion. So you can use this one as your reviewer. Okay, pero I would be providing the solution for number 6 to 10. Okay? So, yun lang, that's how we actually solve for uniformly accelerating motion horizontal. And we can actually apply the way we solved horizontal motion doon sa next topic natin, which is the vertical. So, it would be really um, tawag nito, beneficial on your part if you're going to practice solving problems. Lahat ng binigay ko sa inyo na practice exercises, you do it. Kasi, ganun nyo rin gagawin yung susunod na topic, which is vertical. More or less, that's how we will be able to solve the problems for the next topic, which is the free fall, as well as the combination or the projectile motion. Okay? So I will just end this one. I hope that you learned something from this video. Thank you.